Light Part 1. When light is not always instant. In the minds of ancient humans, light was both a miracle and a familiar force. Every day, they watched the sun rise and set, saw flames ignite from wood, and witnessed darkness vanish the moment a candle was lit. Everything seemed to happen instantly, as if light required no time to be present. That perception deeply embedded itself into human understanding. Light was instantaneous, divine. But the truth, like every mystery in the universe, waited for those patient and bold enough to lift the veil. When the universe whispered something different. In the 17th century, Europe entered a time of dramatic transformation. The telescope emerged, bringing with it a new class of observationists and astronomers who no longer accepted metaphysical explanations. They looked up and saw order in the sky. In that era, a Danish man named Rømer, working at the Paris Observatory, became fascinated with a giant planet and the small moons orbiting at Jupiter and its moon Io. He wasn't searching for light, he was looking for precision. Io orbited Jupiter like clockwork, but not perfectly. Sometimes, Io appeared early. Why? With remarkable insight, Rømer realized the irregularity wasn't with Jupiter or its moons, it was with us. Earth wasn't stationary. When Earth was closer to Jupiter, the light from Io arrived faster. When it was farther, the light came later. Rømer proposed a then unthinkable idea: light needed time to travel. Using the distance between Earth and Jupiter, he estimated the speed of light to be about 214,000 kilometers per second, an imprecise number by today's standards, but revolutionary. For the first time in human history, someone had measured the speed of light not with a ruler, but with intellect and the sky. Raindrops from the stars and an imaginary umbrella. Half a century later, an Englishman named James Bradley continued the journey. But he didn't study Jupiter or its moons, he observed distant stars and how their positions slightly shifted with the seasons. At first, he thought it might be an optical error. But the pattern was consistent. Then he had a profound thought. Light from the stars was arriving as Earth moved, like someone walking through rain. When you walk through rain that falls vertically, you tilt your umbrella forward. Not because the rain is slanted, but because you're moving. Similarly, the starlight seemed tilted, not because of star movement, but because Earth was orbiting the Sun. From this, Bradley estimated the speed of light as about 301,000 kilometers per second. No more doubt light had a finite speed. And humanity was inching closer to understanding its nature. Pulling light down to Earth. By the mid-19th century, scientists weren't content with gazing at the heavens. They wanted to bring light into the laboratory to dissect it under the microscope of logic and experiment. Armand Fizeau, a French physicist, proposed a bold experiment using a rapidly spinning toothed wheel. He shone a beam of light through the gaps between teeth, reflected it from a mirror several kilometers away, and back through the same gap. If the wheel spun fast enough, the returning light would be blocked by the next tooth. By adjusting the rotation speed, Fizeau could calculate the speed of light. His result: 315,000 kilometers per second, the first time light speed was measured on Earth using mechanical tools. Soon after, Leon Foucault, a colleague, improved the setup by replacing the wheel with a rotating mirror. This gave better precision, yielding a value of 298,000 kilometers per second. More importantly, Foucault demonstrated that light traveled slower in water than in air, supporting the wave theory of light. The Great Light Hunter. In the late 19th century, Albert Michelson, an American physicist, became a pioneer in precisely measuring the speed of light. Using rotating mirrors and long distances, including mountaintop observatories, he steadily refined the measurements. Michelson didn't just measure light, he lived it. He believed understanding light's speed was the key to understanding the universe. And he was likely right. Together with Edward Morley, Michelson conducted the famous Michelson-Morley experiment to prove that light needed a medium to travel through, called the ether. But to their surprise, they found none. Light required no medium. This fundamentally challenged classical Newtonian physics. Meanwhile, in Scotland, a silent revolution was underway. When electricity and magnetism sang in unison. In the 1860s, James Clerk Maxwell combined the laws of electricity and magnetism into a single set of equations. When he solved them, he found something extraordinary: electric waves existed, and their speed matched the speed of light. This couldn't be a coincidence. Maxwell declared that light was an electromagnetic wave. By doing so, he unified to previously separate fields, electricity and magnetism, and placed light within a coherent physical framework. It wasn't just a scientific breakthrough, it redefined our understanding of reality. Light Part 2, when Einstein rewrites space and time. Light, after centuries of pursuit by thinkers, astronomers, and experimenters, was finally placed at the heart of a knowledge revolution. A revolution that would reshape the very structure of the universe we live in. No longer was there doubt. Light is not instantaneous, it has a finite speed. But this raised a deeper question: why is that speed an absolute limit? When time and space begin to stretch. In 1905, a young man working at the Swiss Patent Office, without a title or laboratory, possessed a sharp mind and a rebellious spirit toward reality. His name was Albert Einstein. In what's now called the Annus Mirabilis, the miraculous year, Einstein published 4 scientific papers that shook the foundations of physics. One of them laid the groundwork for the special theory of relativity. Einstein didn't try to explain light through the ether like those before him. Instead, he removed ether entirely from the universe. And he made a bold, yet simple claim: the speed of light in a vacuum is the same for all observers, regardless of how they are moving. Whether you're standing still or on a spaceship moving at extreme speed, you still measure the speed of light as exactly the same, no faster, no slower. This defied Newtonian logic, which would expect speeds to add or subtract. For example, if you run toward a light source, you'd expect it to reach you faster. But no, Einstein said the light would still travel at the same speed. Instead, space and time around you would adjust. Space contracts, time slows. From to simple postulates. 1. The laws of physics are the same in all inertial reference frames. 2. The speed of light in a vacuum is constant for all observers. Einstein derived profound consequences. Time is relative. The faster you move, the slower time flows for you, called time dilation. Length shortens. Objects moving fast appear shortened along their direction of motion, called length contraction. There is no absolute present. What now means varies between observers depending on their motion. Above all, light speed became the ultimate limit. Nothing, no matter, no signal, no thought can travel faster. Light speed and causality. Why does this matter? Because it protects the most fundamental principle of the universe, causality. Einstein described that each event in space, say, flipping on a light, has a region of influence, called the future light cone. Everything that the light from this event can reach lies within that cone. Conversely, the past light cone includes all events that could have influenced it via light. Outside these cones lies the region of no causal contact, where no event can affect another without violating the speed of light. Thus, the speed of light is the golden thread that weaves the logical order of the cosmos. Spacetime, the union of two realms. Every point in the universe is not just defined by x, y, z, but also by a time coordinate. Objects don't just move through space, but through spacetime, guided by the constraint of light speed. Light speed is not just the speed of photons. It's a structural constant. It defines how space and time intertwine. When you accelerate, you lean more toward the time axis. When at rest, you flow through time at maximum speed. When traveling at light speed, you no longer experience time. To Einstein, light is the yardstick of causality, the boundary between the possible and the impossible. Why this number? So now the great question remains, why is the speed of light 299,792,458 meters per second? Why not another number? The answer: we don't know. Light speed isn't derived from other physical laws. It is a fundamental constant of nature, like Planck's constant or the charge of the electron. In fact, scientists have defined the meter based on the speed of light, not the other way around. That is, light speed is no longer just measured, it is the basis from which other units are built. Perhaps in another universe, the speed of light is different, leading to entirely different physics. But in this one, C is the eternal limit, our reality's destiny. Light messages from the past. The finite speed of light is not just a barrier. It's a gift. It allows us to see the past of the universe. When you look at a star, you're not seeing it as it is now, but as it was. If a star is 1,000 light years away, its light took 1,000 years to reach us. Likewise, when you observe the Andromeda galaxy, you are seeing it as it was 2.5 million years ago, before modern humans existed. Light speed, thus, turns the cosmos into a natural time machine. Every beam is a message from the past, a letter of light sent forward in time, and you are its reader. Conclusion: the universe is woven with light. From Rømer to Bradley, from Fizeau to Michelson, from Maxwell to Einstein, the journey to understand light is a journey to redefine our place in the universe. From thinking light was instantaneous and divine, we have learned light has speed. That speed is invariant. That speed defines what can and cannot happen. That speed builds causality, order, and time. It is the supreme law, the eternal fabric of spacetime, the whisper of the universe about our limits and our greatness.